All right, we're going to go through the homework in chapter 23. All right. All right, if we go in order, that would be a good thing to do. We have number 2, which is probably the hardest question in the homework. So when you're doing 23.2, it says to draw the structural isomers of the 5 isomers of C6H14. All right, so we have C6H14. All right, and so that's the way I want to do it. All right. All right, so either way, the two things that I wrote there are exactly the same. I have 6 carbons. I like to do it in a line stick model. And so the 6 things here that I put a dot by, those are indicating your carbons. Or you can write 6 carbons, actually write out the letter C. All right, they all have to have 4 bonds. So this is a CH3, this is a CH2, this is a CH2, this is a CH2, this is a CH2, and this is a CH3. All right, and so we know that this formula is in the CnH2n plus 2. So we know it's an alkane. So that is the molecular formula for an alkane. All right, so you can put 6, and that is the hexane. So 6 carbons in a row, that is your hexane. So that is one of the 5 isomers. All right, so that's it for 6 in a row. And so then you got to go to 5. All right, you can't put 1 at either end because then that would be 6 in a row, and that would be your hexane. So you can put it here. And if you're writing it in a line stick model, you can put it here. That would be the same thing. All right, and so again, you give everything the 4 bonds. You've got your CH3s. This only has 3 bonds. It only needs 1 H. This one needs 2. This one needs 2. This one needs 3. All right, it's going to add up to 14. If you have an alkane and 6 carbons, you have to have 14 hydrogens. All right, so they will all add up to 14 hydrogens. And so when you name it, you give the longest carbon chain, which is 5, but you got to start at the end closest to the first group coming off, and that is this side. You might get questions that say, somebody named this as a 4-methyl pentane, and what is the correct name? Well, you can write 4-methyl pentane. That would be just putting it in the wrong direction for numbering carbons, and see that this is a 2-methyl pentane. All right, so that is 5 in a row, but there is another place that you can put that 6 carbon. All right, so if you put it on either one of these, you're back to the 2. If you put it on the end, then you're 6 in a row, but you could put it here. So you could have your 5 carbons and put it off the carbon that is in the middle. All right, so you got your H3, your H2, your H, H3. You put in the H's so that all these carbons have 4 bonds. CH3 at the end. So carbon has to have 4 bonds. And when you add them up, they will be 14 H's. All right, this one doesn't matter which way you number it, because either way, number 3 is the carbon that has the methyl. So this is a 3-methyl pentane. And anytime you have a question that says give the different isomers, you should definitely name them, because If you're naming them systematically and if you have the same name, you drew the same compound. It may visually look different, but it is the same compound. All right, so that is it for 5 in a row. If we again put it at either the other two, you're back to a hexane, you're back to a 2-methyl. All right, so now we go to 4 carbons in a row. So carbon, 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 carbon. All right, we cannot put a carbon on either end, because if we put a carbon on either end, then we have 5 in a row. So you can only put the next 2 carbons in the middle. And so you can put a carbon here, and then you can also put a carbon here. All right, if we go back to the 4 in a row and we can't put it here, we can't put it here, well, we could put 1 carbon here and 1 carbon here. All right, now what you might say is I have 2 carbons. So how about if I put both carbons here? Or I put both carbons here. All right, but now you don't have, your longest carbon chain is no longer 4. Again, you don't go from left to right. You don't go from right to left. You go in the direction that has the longest continuous carbon chain, and that would be in this case 5. And that would be in this case 5. We already did the 5s. These are repeats. Again, you might visually think that those are different, but if you name them correctly by going to the longest carbon chain, you will see that it has the same name as previous. All right, and so again, if you're doing the line stick model, first one I did has a carbon there, and then the second one I did had a carbon here and here. All right, and so if you're putting in your H's, you got 3 that are required there, 1 here, 3 here, 3 here, 1 here, 3 here. Again, they're all going to add up to 14. This one has CH3, CH3, CH3. The carbon here already has 4 bonds, doesn't need any hydrogens. This is CH2 and this is CH3. And so when we number it, for the first one, it doesn't matter. 1, 2, 3, 4, you have 2 and 3, or if you go the other way, you still have 2 and 3. And so this one is a 2,3-dimethyl. 4 carbons in a row is butane. And this one, 1, 2, 3, 4, you have to go that way. If you went the other way, it would be a 3,3-dimethyl. You have to give it the way that has the lowest numbers. And so this one is a 2,2-dimethyl butane. All right, so the first question is one of the hardest ones on the homework, and that is give the 5 structural isomers for C6H14. And then you would also need to name those. It doesn't say that, but it would on the test that you would also have to give the name for those. Note that we haven't talked much about stereoisomers except for cis and trans. So when you have any questions on stereoisomers, it is the 3-dimensional makeup of your compound. A structural isomer, you have different ways that the carbons align. When you had stereoisomers and you had your compound that looked like this, and you have your compound, it's an ugly H, that looks like this, what you would say would be it'd be exactly the same thing. Connectivity would be the same. Here you have a CH3 connected to a CH, double bonded to a CH, connected to a CH3. You'd say the exact same thing here. You have a CH3 connected to a CH, double bonded to a CH, connected to a CH3. All right, and so they are different in the way that they are 3-dimensionally aligned, and so those are called stereoisomers, where we have, of course, a cis to butene, and we have a trans to butene. All right, so these will be on the test for sure and will not be extra credit. However, there may be some on the test, and if they are, they would be extra credit because these are a lot more difficult, and they are chiral carbons. So if you have a chiral carbon, that means you have a carbon connected to 4 different groups. So a carbon connected to 4 different groups. All right, and so groups is important because if you have it attached to a methyl and you attach to an ethyl, those are different groups. Both attached to carbon, but different groups. You have a methyl group and you have a ethyl group. All right, and so if you have a chiral carbon, the mirror image would not be the same. It was not superimposable. So let's do an example of a chiral carbon. All right, and so you have to have 4 different groups connected, which indicates that the carbon has to be an sp3 carbon and tetrahedral. So you cannot have a chiral carbon unless you have an sp3 carbon and it must be tetrahedral. So that's the only way you can get 4 different groups on a carbon. If you have a double bond, that would be 2 of the same thing. It's going to 2 of the same thing. You can't have 4 different groups when there's only 3 possible. All right, and so you have to have 4 different groups. So let's put the H here. Let's put a CH3 here. We'll put a CH2, CH3 here. And we'll put a CH2, CH2, CH3 here. All right, and so if we were to name this, we would have to find the longest carbon chain. All right, and so the longest carbon chain is 1, 2, 3, 4, 5, 6. And so we have a hexane. All right, and so off of carbon 3, we have a methyl. So we have a 3-methyl hexane. All right, and just like you will have a cis and trans, for this you will have a mirror image, though, not your cis and trans is not a mirror image. Cis and trans is a different type of stereoisomer. It is a geometric isomer. These are called enantiomers. All right, and when you take the mirror image of this, what you see in the mirror is this. And so again, you have 3-methyl hexane. Just like when you had your cis and trans, it was still your 2-butene. You had cis-2-butene, you had trans-2-butene. All right, when you have a chiral carbon, that means a carbon connected to 4 different groups. You have a naming system that is not cis-trans. It is going to be called RS, where R goes clockwise and S is counterclockwise. Again, if any of this is on the test, it would be extra credit. You don't have to spend a whole lot of time. I just want to introduce chiral carbons. It is very important for naming organic compounds, but we're not going to really, if there's a question, it's going to be extra credit. All right, and so what you would do is you would assign the largest group A1, then the second largest group A2. So propyl is larger than ethyl, is larger than methyl. And then the smallest group is an H. All right, so you would number the groups from smallest or largest to smallest, 1, 2, 3, 4. Then when you do that, you would follow your 1, your 2, and your 3, with 4 going back, and then see if it's going clockwise or counterclockwise. All right, and so you see that this one is going clockwise. And so this one would be called an R3-methyl hexane. And then if you did the mirror image correctly, it has to go the other direction because that's how we know the difference. 1, 2, 3, 4 group coming back, and then of course you have counterclockwise, and this is S. And so instead of cis and trans, you use R and S. If it's clockwise, it's R. If it's counterclockwise, it's S. The only thing you're going to be doing is identifying a chiral carbon. So to identify a chiral carbon, it is the carbon that is connected to 4 different groups. So if the question says, are there any chiral carbons, and you find the one that has the 4 different groups, then you can get extra credit for that. All right, so I don't think there's going to be any questions on chiral carbons. We're going to hit chiral carbons quite a bit for the next test because we have L-amino acids, we have D classes of sugars. These are all about a chiral carbon. All right, number 10. Write the structure of propyl benzene. All right, so you have to know all of your groups. You got to know methyl, you got to know ethyl, and of course, you've got to know propyl. All right, so propyl has 3 carbons, ethyl has 2 carbons, methyl has 1 carbon. All right, so you have to then also know what benzene is. And so benzene is a 6-membered ring. All right, so benzene is a 6-membered ring, and remember that the 6-membered ring is conjugated, alternating single and double bonds. You can write it with a circle, or you can write it with alternating single and double bonds. And so this is your benzene. So in order to get this problem right, you have to know what benzene is, and you have to know what propyl is. And then you have to be able to put it together. And then you put your propyl off of your benzene. Every spot on your benzene is the same. It doesn't matter which one you pick. So here is propyl benzene. So that is, did you memorize it or did you not? It doesn't get any easier than a propyl benzene. All right, but then it also asks for a P-dichlorobenzene. All right, so here you have to even know more about your benzene. And that is, you have to know the difference between an ortho, a meta, and a para. So this is ortho when you're off of the 1 and 2. This, if you're off of 1 and 3, is meta. And when you're off the opposite ends, 1, 4, now you are para. And so you have to know, ortho, you would put them here, meta, you'd put them there, para there. So the question is, what is para-dichlorobenzene? And so you are putting chlorine groups in the para position of a benzene. All right, and so then you have your para-dichlorobenzene. One of the most common errors is to not know the difference between benzene and cyclohexane. This is cyclohexane. And if, of course, you can say, well, I just forgot to put the circle. Well, maybe you wrote cyclohexane. So I can't tell the difference. If you write cyclohexane, you wrote cyclohexane. You didn't, whatever. If you have a circle in the middle, that's benzene. So again, these are very similar. Do not forget to put the circle, because if you do, you have a completely different compound. All right, so when you have benzene, make sure you put the circle. Also, know that the circle in the middle means that you have an alternating single double bond system. All right. So yeah, you can write it with the double bonds or the circle, but you cannot leave it without a circle or the double bonds, because then you have cyclohexane. All right, 2314. Identify and name the functional groups in each of the following. All right, so we have, all right, so this is interesting because you have to be able to go from this type of condensed structural formula. All right, so again, you have to know that there's 4 bonds to carbon, 2 bonds to oxygen, 1 bond to hydrogen. All right, if you don't have this, well, then you 100% have the wrong answer. All right, so you can show all the individual bonds to make sure that you see that this carbon has 4 bonds. And now the next carbon has an O and a CH3. So most people that haven't done their homework are going to put this as the answer. And they will circle it and not see a thing wrong with that, okay? Except for this carbon, obviously, only has 2 bonds, all right? Which is always wrong. If your carbon does not have 4 bonds, there is a 100% chance that you have the wrong answer. All right, so the usual wrong answer that I get for this is right here. You have to see that every carbon has to have 4 bonds. All right, so to get 4 bonds, you have to have a double bond to that oxygen and then bond it to a CH3. That is the only way. All right, and when you write the structure this way, this carbon must have the 3 H's attached. This carbon must have the 3 H's attached. All right, so this is not a formula that they gave at the very beginning. This is not a molecular formula. They didn't say do Ch3 Ch2 which is the molecular formula. They gave the condensed structural formula. And when you give the condensed structural formula, the CH3, that means that C must be attached to these 3 H's. This C must be attached to this O. This C must be attached to those 3 H's. All right, and so when you get your structure, that the carbons attached to those 3 H's, that one's, and this one's to the O, and you have 4 bonds and 2 bonds and 1 bond. All right, so now you have your structure. You have all of these have been fulfilled. 4 bonds to every carbon, 2 bonds to every oxygen, 1 bond to every hydrogen. All right, that's not even the question. It says to name the functional group, all right, which is a bad question. You should circle the functional group and name the class of compound, all right, because the name of this functional group is a carbonyl. They're, I don't think, looking for carbonyl. They're looking for the class of compound. So you circle the functional group, and then the class of compound is a ketone. And if you spell ketone with a Y, I don't take it off, but it is not with a Y. Ketone is spelled Ketone. All right, so that is your ketone. All right, and so you will have to name it on the test. Longest carbon chain is 3, so that is a propane. When you have a ketone, you drop the E, you add -one. And so this is propanone. All right, so this is a lowest number for the double bond. So you have a 2-propanone. All right, again, no one would call this 2-propanone. Everyone will call this acetone. So if it says to name it and you name it 2-propanone, great. If you name it propanone, great. If you name it acetone, great. If you name it dimethylketone, great. If you name it anything else, it's the wrong answer. All right, so there's not just one correct answer a lot of times for naming, but there are an infinite number of wrong answers, but there are many times more than one, but not every time. Sometimes there is only one correct name. All right, CH3, CH, double bond, CH2. All right, and so anytime you have a double bond, so I would circle my functional group and say that is an alkene. All right, so the double bond is the functional group, the alkene is the class of compound, and then you will name it. 1, 2, 3, again, is the longest carbon chain, so that is a propene. So it is a alkene, and it's going to end in -ene. All right, and then, of course, if you're not sure, go ahead and put it. You don't need it, but I would always put the number for your alkene. The only ones that do not need the 1 would be a propene or an ethene, 2 carbons or 3 carbons. Everything else would require the number where the double bond starts. So this is a 1-propene, or of course propene is the better name, but either one would be full credit. All right, so the next one is CH3, CH2, CHO. All right, and so if you are following along, you have to have 4 bonds to every carbon. The CH3 has to stay together, and so that's connected to a CH2. That 2 H's has to stay on that carbon, bonded to a CH, which has to be on that carbon. The O cannot go on the H because H can only have 1 bond. This carbon is not done because it only has 2 bonds. Oxygen has to have 2 bonds. Carbon has to have 4 bonds. So obviously you have to put a double bond O here to give your carbon your 4 bonds, your oxygen your 2 bonds, and now you see that you have an aldehyde. All right, The functional group for an aldehyde is a carbonyl, or you could say it has the formal group on it. But of course, they're not looking for that. They're looking, you circle the functional group, and you say that is the functional group for an aldehyde. Longest carbon chain for the aldehyde never gets a number because the C double bond O is always number 1. For your ketone, it's the lowest number possible. For your aldehyde, it's always carbon number 1. And so, again, when you're doing an aldehyde, you drop the E and you add al, A-L, aldehyde. All right, so you have a propan, and now you drop the E of propane, and you add Al. You have propanal. If you put a 1 for the aldehyde, I may take off some points. Never use a number for aldehydes. It is always a 1. All right, so here we have CH3O, CH2, CH3. All right, so most people get this one right because if you just write it straight across, you have the right answer. All right, because CH3 has to be together, and then your O has to have 2 bonds, and it would if you put it with the CH2 and then your CH3. All right, so this one is very easy to go from a condensed formula to a detailed structural formula. All right, and so your functional group is your oxygen between 2 carbons. All right, that's an ether. And so, again, you can name this one of 2 ways. The way I would expect people to name it is the group on this side is methyl, the group on this side is ethyl, and you would put it in alphabetical order and give it as ethyl, methyl, ether. All right, so if you do not have the ethyl group and methyl group memorized, you must have the ethyl group and methyl group memorized. You have to have all your functional groups memorized. All right, so you have to recognize that, circle that. I'm looking at the O, and that's an ether. And here's the name. You could give the Upac name where you have longest carbon chain is 2. So that is ethane. Off of carbon 1, you have a methyl with an oxygen. So you have a methoxy. You don't need the 1, but you can put the 1 and you would not lose points because you will need the numbers once you get past 3 carbons of your longest carbon chain. All right, the next one is a CH3, CH2, COOH. Again, this one people will get wrong all the time, but you have to put 4 bonds to carbon. So your first one is CH3. Got to keep that together. Then that's connected to a CH2. That C must have the 2 H's. And then you have a C with an O and an O and an H. All right, so that one takes some practice. The previous one doesn't take much practice. You just go in a straight line. If you do this one in a straight line and you say it's C, O, O, and H, well, your O's have 2 bonds. Your H has 1 bond, but this carbon is only going to have 2 bonds. All right, so when you have a COOH, you have to put a double bond to one of the oxygens and then an OH to the other oxygen. And then you see that you have a carboxylic acid. All right, and when you number it, you got 3 carbons. A carboxylic acid never gets the number 1 because that carbon is always carbon number 1. And so to name a carboxylic acid, you drop the E and you add oic acid. And so you have propan. So it would be propane. You drop the E. 3 carbons is propane. You drop the E. You add oic acid. Propanoic acid. All right, never put the 1 for a carboxylic acid. It is always carbon 1 where the C double bond O is. All right, and then the last one on there is a CH3, CH2, Ch2 OH. This one, if you just wrote it straight across, again, you would get the right answer for this one. All right, so about half of them you would get the right answer, and the other half you would not. All right, so you got your CH3 connected to a CH2, connected to a CH2, connected to an OH. All right, and so when you're done, you do that. You see every carbon has 4 bonds, every oxygen has 2 bonds, every hydrogen has 1 bond. Yes, that is your structure, your structural formula. So longest carbon chain, lowest number for the OH. So we're going to start numbering from this side. How do I unselect that? Not that way. I don't know what's going on. All right, and so you have 3 carbons, and so you have your propane. You circle your OH, that is an alcohol. This is going crazy. All right. All right, well, it's writing again. All right, so you have your propane, you have an alcohol, you drop the E and add OL. All right, so you have propanol, but here you must put the 1. So you have a 1 propanol. And anytime you have an alcohol, you should also label it as primary, secondary, or tertiary. Since that carbon connected to the OH has 1 carbon and 2 hydrogens, this is a primary alcohol. All right. 16. Which of the following could exist as cis-trans? All right, so what you're looking for here is, well, you're going to have a double bond for cis-trans. What the heck is going on here? It's erasing stuff as I write it. All right, and you have to have 2 different groups. All right, let's see if this helps. I doubt it, but you never know. All right, back to what's going on. All right. So in order to have a cis and trans, you have to have, I'm going to go with 1, 2, and then you can have another 1, 2. Basically, that these cannot be the same. So if you have the same group on this side, or if you have the same group on that side, all right, then you cannot have cis and trans. So if this is the same, so if that's the same as this, a 1 and say a 1, and this is a 1, 2, you cannot have cis and trans. If you have a double bond, whatever, this is 1 and 2, but the other side is whatever, 1 and 1. All right, you cannot have cis and trans. If you have the same group on one of the carbons of the double bond, there's no cis trans. You have to have different things on the left. You have to have different things on the right. All right, so when you look at the first one, you have not even a double bond. All right, so you have CH3, CH2, CH2, CH3. Now so alkanes can never be cis-trans. All right, so alkane, never cis-trans. However, cycloalkane can be cis and trans. All right, so the only other thing that could be cis-trans is a cycloalkane. All right, but we're going to stick with the alkenes for this test. All right, so the next one is also an alkane. So if you look at the next one, CH3, CH, CH3, and then a CH2 and a CH3, that is an alkane. And no cis-trans. All right, so for this, you're looking for your alkene. All right, so here you've got a CH3, and I believe in my book it says C here, and that's connected to a CH3 down here, and that's connected to a CH2. All right, and so you have then a double bond, because 4 bonds to every carbon. This one only had 3, that one only had 3. So you know you have to put in a double bond. So this is the same on this side. So you can look at that side and see it as the same. And it's the same on this side. It doesn't have to be the same on both sides. It only has to be the same on one side in order to not have cis-trans. This is the same on both sides, and so no cis-trans. All right, but if you didn't have to have the same thing on both sides, one side or the other, or of course both sides also works, you will not have any cis-trans. All right, and so the last one here is CH3, CH, CH, CH3. So when you write that structure out, CH3, then you have your CH, and then you have your CH, and then you have your CH3. And if you write it like this, you see that you do not have 4 bonds to every carbon. You got 4 bonds to the first and last carbon, but you do not have 4 bonds to the middle carbon. And that's because you need a double bond to go in here in order for all of your carbons to have 4 bonds. Now, on this side, you have a methyl and you have a hydrogen. Those are different. You have on the other side a hydrogen and a methyl. Those are different. So yes, you will have cis-trans. All right, the one that I drew was trans. One's going up, one's going down. They are on opposite sides. That is trans. You could put another one where they're both going either up or both going either down, and that would be a cis arrangement. All right, 2318. What is the correct Upac name for this compound? All right, so you got CH3, CH2, then it comes down here to CH2, CH, CH2, and then it goes down here to OH, and then it goes up here to a CH2, CH3. All right, so rule number 1 is find the longest carbon chain. And so 1, 2, 3, 4, 5, 6, 7. All right, where the OH is number 4. If you go the other direction, 1, 2, 3, 4, 5, 6, and 7. Either way, the OH has the number 4. So 7 is heptane. All right, and you see that you have an OH, so you know it's an alcohol. So you know you're going to drop the E, and you're going to add OL. And so this is a heptane. 7 carbons is heptane. We drop the E, we add OL, we have heptanol, and the OH is on carbon number 4. So we have a 4-heptanol. And again, anytime we have an alcohol, we should label it as primary, secondary, or tertiary. So the carbon attached to this OH is connected to one H and two carbons, and that is a secondary alcohol. All right, 2320. All right, 3-propyl hexane. So 3-propyl hexane. All right, so somebody named the compound 3-propyl hexane, and the question is, did this compound get named correctly? And so hexane is 6 carbons in a row. 1, 2, 3, 4, 5, 6. And then off of carbon number 3, we have the propyl group, which is a 3-carbon chain. So you have to know propyl is CH2, CH2, CH3. So this is your propyl group, CH2, CH2, CH3. All right, you plug in your H's so that all of your carbons have 4 bonds. All right, and so the question is, well, is this the correct name? And the answer is no, because you give the longest carbon chain. The longest carbon chain is not 7. If you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, okay, 7. All right, you see that, oh, it's hexane. I don't know why I'm doing heptane. All right, fine. 6 is hexane. Heptane is up here. Okay. Hexane is right here. So 6 carbons, right? All right. 6 is not the longest carbon chain because you could have gone from down here and went 1, 2, 3, 4, 5, 6, 7. So now it is a heptane. So the longest carbon chain of 3-propyl hexane is not 6. The longest carbon chain is 7. And off of carbon number 4, 1, 2, 3, off of carbon number 4, so I will wipe out these 6. Off of carbon number 4, we have a CH2, CH3. All right, so we have a 4-ethyl heptane. What if we number it the other way? 1, 2, 3, and 4. It is still a 4. 4-ethyl heptane is the correct name. All right, so 3-propyl hexane is named incorrectly because it did not use the longest carbon chain. If you use the longest carbon chain, then the name is 3-ethyl heptane. And so 3-propyl hexane, if you named it as 3-propyl hexane, that is the wrong answer. The only correct answer for this one is 4-ethyl heptane. All right, so the way they drew it on the paper was just like I drew it. And so, of course, you don't just go from left to right. You have to go any direction that gives you the longest carbon chain. All right, 2323. Okay, so we have, all right, so this is a model kit. So you have to see that you have a CH3 connected to a nitrogen, connected to a CH3, connected to a CH3. All right, in this model, okay, that's the first one. We just writing the structures. Looks like we're just writing the structures. All right, unfortunately, they are color-coded, and I have a black and white piece of paper, so which is fine. The next one would be a CH3, and then you got a C double bond O to H. I don't need the colors. I can see that this, one of the compounds here has 3 bonds, and so that has to be a nitrogen. Any of them that have 4 bonds have to be carbon. 1 bond has to be hydrogen. 2 bonds has to be oxygen. I don't need the actual colors to know what the atom is. So you got a CH3, then you got a CH with an OH, and then you got a CH3. And then the one below that, you got a CH3, and then a C double bond O, and an OH. And then over here, you've got a CH2 5 times. And then here, you got a lot of stuff. You got a CH3 to a C to a CH3 to another CH3 to a CH2. And that's connected to a CH, which is connected to a CH3 and connected to a CH3. All right, and so once we have the formulas, then we can name them. All right, so let's just name this one here. Longest carbon chain, 1, 2, 3, 4, and 5. All right, so we have a methyl off of 2, another methyl off of 2, and a methyl off of 4. So 5 is a pentane. And we have a 2, 2, 4 trimethyl pentane. If you have 3 methyls, you have to have tri. You will have 3 numbers and tri. This is simply cyclopentane. This one is a carboxylic acid, 2 carbons, so this is ethanoic acid. This is a 3 carbon alcohol. This is a 2 propanol. This is a 2 carbon aldehyde. This is ethanal. And this one is an amine with 3 methyls, and so that one is trimethyl amine. So your amines will be labeled as primary, secondary, tertiary. When you have 3 carbon-nitrogen bonds, that one is tertiary. Your oxygen, your alcohols will also be primary, secondary, tertiary. When your carbon attached to it is connected to 2 other carbons, that is a secondary alcohol. All right, we will do more homework tomorrow.